Welcome to Chapter 2. This is Section 2.1, which is Function Notation, which is a review of much of the material you covered back years past, where you are going to basically be replacing values within functions to find the value of the function. And just to illustrate again what a function is, it's a relationship between two values. And the blue here is talking about the area of a square. And we all know how to find the area of a square. It's just the side times the side. But it's fair to say then that the area totally depends on the side length. And another way to say that is that the area is a function of the side length. And normally we don't deal with area and side length. We normally deal with y values and x values and domains and ranges. And the range is a function of the domain, just like the area is a function of the side length. The y value is a function of x, and that's why we can sometimes and often do replace y with what we call f of x, or a function of x. And the problems you're going to deal with today are going to be such like this. So if we look at the first, we're going to find the value of this function, which we know is a parabola that opens down. We're going to find its value at -1. So what do? We replace x with -1. In question B, a little bit more abstract, what's the function's value when we replace x with 3k? And then, well, even a little stranger, what if we replace x with 2 plus h? And I just wanted to show you this one, just to remind you that when you replace, sorry, that should be a minus sign, when you replace x squared with 2 plus h, that you have to make sure you do the correct binomial expansion here. 2 plus h squared, remember, is 4 plus 4h plus h squared. So just watch that when you do your assignment. Also watch tricky ones where you might have a x on the bottom. You have to be careful with that. Remember, then there might be a restriction on the variable, that x is undefined at a certain point. Similarly, you're going to run into questions that look like this quite often in the next section regarding something that we call the derivative. And so this is a practice with that, and I'll just give you a little bit of a preview in that every time you do a question like that, what should happen is that h is going to cancel out. So if you're having trouble with that one, make sure you ask me later on. In question F, it's an opposite question. It's saying, well, if the function's value is -31, and the function is defined as being 1 minus 4x plus x squared minus x squared, then what's the value of x? And so we would move this to the other side by adding 32 to both sides. And we would solve it by factoring. If we can't factor, we know how to use the quadratic formula, and we can handle it. Notice that should be a t, not an x, but that's a small thing. This question is very similar as well. It's just saying, what if you replace the value with -2 plus w, or -2 minus w? If we fill those both in, 4x, that they have to equal one another, and then we're going to solve for w instead of 4x. And if you look at a question in your textbook, they'll also have a graph where you have to look at the graph and find, well, if the x value is 1, what's the value of the y, or the g, the value of the function g at x being 1 or -4 or 3.5. And then the opposite is also asked, what if the y value or the function's value is 0, then what's the x value that goes with it? And you'll see that when you do your assignment. Otherwise, that's it. I don't think you're going to have too much trouble with function notation. It is a review assignment for you, and I'll help you as you do your assignment.